3, 2, 1. Hi everyone, Gleb Bakhmuter from Cypress IO is here. I hope you're doing well, I hope you're staying at home and staying healthy. Let me ask you a question. Have you heard of fast and effective end-to-end tests? Sounds like an oxymoron. Let's find out more. Before we do that, I have to say that our planet is in immediate danger, and we are soon on a path to destruction. We have to act today. I'm doing my part by buying solar electricity, by using my e-bike, and by using online conferences like this one instead of flying. But it's not just me, it's us. Please join an organization in your area that tries to fight climate crisis. If you know of any company that works on climate solutions, I volunteer to help for free. It could be profit, non-profit, I don't care, I'll help. Okay. I have a long history in open source. I have all my projects linked from my website. I have a bunch of blog posts that I write for myself at my blog. And I've been with Cypress for 3 years. These slides are already online at slides.com. If you want to ask a question or provide feedback, you can tweet at me at Bakhmutov on Twitter. So I found this app on Code Sandbox and I found very good blog post. It's a modern React application that uses hooks and has a couple of components, and all it does, it creates to-dos, and it's working. Nice. I can add to-dos, I can mark them complete, I can delete to-dos, and I can add one more. It's a modern application, but if, for example, I want to change this button from just completing an item to complete and mark item as not done, like toggling a button, I have to write some tests. So if I give you a modern web application, how fast can you change it if you have to write tests first? Let's look at this. We'll start a timer. So by the way, all the source code that I'm about to show is on my GitHub profile. Check it out. First thing I usually do is I do npm install Cypress because I work at Cypress. That takes a minute. Then I write a test, and the first complete test that I would write describes a to-do application. I would visit the site using site-visit. This command actually loads the site in a real browser like a real user would. And then I would find all elements with class to-do. And then I assert that there are 3 items at the beginning. These items are hard-coded by the application. It's a typical test. But even to run the test, I have to start the application. It's a local React scripts application, so I have to start it first. We want to remove this obstacle, so we write all these little utilities in addition to writing Cypress, that allows you to start testing faster. In this case, I install both Cypress and start server and test, and this little utility comes in very, very handy. For example, React scripts application that I'm working with has a start script. It just calls React scripts that opens web application and runs it on port 3000. And then we want to open Cypress. So what will I do locally? I will run a script dev that uses start test ls. By default, it will run npm start. In this case, wait for port 3000 to respond, and once it responds, then it will call npm run sciopen, opening Cypress. When Cypress starts, it shows me this screen. It shows that I only have a single to-do spec test file. On the right, it shows a drop-down. By default, Cypress comes with Electron browser, but Cypress looks around on my operating system and finds all the browsers that I have already installed, and it can use them all: Chrome, Firefox, and Edge, the new Microsoft Edge. So, well, this was my test, right? I can actually confirm more features of my application. I can confirm that I can add a to-do by typing. I can find a to-do, click complete, and then that should have line through. And I can click on an X button for a to-do and remove that item. It should no longer exist because we can no longer meet friends for lunch. It can only be virtual. Here's how it looks in reality. If you click on that to-do spec in Cypress, it opens the browser, and then on the right, you see the application iframed inside the browser. On the left, you see all command commands from the spec file, but shown in a graphical way. So you can see what the application is doing in response to each command. This is a live application. I can do everything myself, just like I can do with actual application in a browser. This is a static screenshot for high resolution. Okay, so that probably takes you 5 minutes if you know what you're doing. If you just write a simple test to load website, maybe do a couple of actions and write a couple of assertions. But the question that I want to ask is, was this an effective test? Or did we just scratch the surface? You know, a ship could be effective if it only carries one item very quickly, or it could be like this container ship carrying millions of items in a single trip. So how effective are the tests? I would call a test effective if it actually touches a lot of application code served in my application. That means a test really exercise and reach all the code source paths that are available. So this problem of computing code coverage from tests has two parts. First, you have to instrument the application source code. That means you have to add special counters that when you execute the code from test will tell you how many times you executed each statement. So we have released a utility that removes it as an obstacle. If you use a React scripts React application, you can install Cypress instrument CRA module and then put it right in between React scripts and start command as a require module. This will load that module first. It will look around, it will insert instrumentation module into your Webpack config, and then your app magically will be instrumented. You can see, if you open DevTools, that there is a special object now on window. It's a new object, it wasn't there before. It has all the application source files under a key, and each file, if you drill down, will have statement counters for statements, for lines, for functions, for branches, telling you how many times each statement or function or branch was actually called during the runtime. Okay, so that was just instrumentation, but now that you run the test, you have to generate reports, save results, do something with that information. So we've written Cypress code coverage npm module. You install it as npm install, and then you add it as a plugin to Cypress itself. So there is one more line that you have to add to plugins file, and then one more line to add to Cypress support file. This will load that plugin in both places, and when you run the test, you will see something interesting. At the end of each test, you will see saving code coverage. Remember, Cypress runs each test in isolation. That means it removes everything inside the iframe and it starts fresh. That means if you had window coverage object, you have to save it, otherwise you will lose it forever. After each test, the plugin does that for you. And when all the tests finish, it has to take that merged coverage information and generate report. And it actually generates reports in a bunch of formats. Some you can send to third-party code coverage services. Other things are for human consumption, like HTML report. So you can say, right after Cypress finishes the test run, open coverage lcov report index.html, and it's self-contained static page. And you can see that one test, right, that we have written in less than 5 minutes covered 96% of all source code in our application. I would call such test very effective. So we're looking at total numbers. You can see also breakdown by each source file, and we can see that app.js was only covered at 96%. We can click on that app.js and it opens a view of each individual file, where on the left you see the counters. And the counters tell you how many times that particular line was executed when the test was running. And so you can see that we covered pretty much all the lines except line number 25, right here. It's a if path. If you actually try to type in empty to do and just click enter, our application doesn't allow that. Well, we never actually exercised that case, right? So we missed that particular branch, that particular statement. So that's why we only covered 25 out of 26 statements. But you can see that with a single test we covered a lot of application. End-to-end tests are very effective at covering apps code. But now let's look at that if statement. How can we actually reach it? Well, we probably should write a test where we get the input box and we type just enter. So those curly brackets and enter, they have a special meaning in Cypress. It just sends a key enter event. And we assert that the number of items is still the same. Now, if we add this to our test and run the test again, well, perfect. 100% code coverage. We covered 100% of code statements, 100% of all branches, 100% of functions, and 100% of source lines. Pretty good, right? People usually set a limit or a minimal code coverage as a number and say our project should reach 80% of source lines covered by test, or 90, or 95, or even 100, which is very hard to do. And we strongly disagree with it. We don't think that code coverage is a number. I think code coverage instead is a guide to the test that you have to write. Remember how I reached 100%? I looked at the source coverage and I figured out what wasn't covered and how to actually exercise that code path by writing end-to-end tests. Like, what does the user have to do to get to that line? I figured it out, written a test, and now I had better code coverage. So the code coverage is a map, not a number of itself, not the ultimate goal. But there is another thing that I observed over and over. When all you have is a hammer, then every problem looks like a nail. But aren't we looking at everything with the same single big hammer approach? Let me explain what I mean. Our application, it's a React app, it has a couple of components. It actually had to do form where you have an input box and you have the app itself. And if you expand the app, it has the utility functions, but also it renders to do and to do form inside. So on the top of our application, kind of big picture view, we have an app, and it has a couple of children components to do form and to do. We didn't actually interact with app directly, no. Index.js takes app component and then renders it in a DOM. And we never actually dealt even with index.js, right? We could only deal with a finished page because we only loaded localhost 3000. So there is a boundary. It's not very strict boundary. Cypress end-to-end tests can easily reach inside the page, inside the DOM, even inside your individual JavaScript code. But we still only go through the whole top pyramid all the way to every component. So what happens if you want to work or change individual to-do component, right? How do you reach and really exercise to-do component in different ways? The only way right now is to go through the whole application, but in that case, you can only do with to-do what app allows it to do, right? How app calls it, how app actually instantiates. What if you want to simulate edge cases? Well, you can't, because you don't work with components, you work with pages. So here's something that we're working on. It's been available for a while, but we're doing some technical things right now that will let this particular type of testing be really, really powerful. So you install additional framework-specific adapter, in this case, Cypress React Unit Test. Remember, Cypress only deals with web application as a whole. It doesn't care what framework we're in, but now we care because we want to work with to-do components. So in this case, it's a React unit test library. And here's how you write the test. This is a test for to-do component. Well, first of all, you import to-do directly from application source code, right? So already unusual. You take this utility method called mount, and then you say, okay, I want to mount to-do, or I want to mount test to do, which you create on the fly. Maybe you put that component inside other components, but you pass local variables just like you do in normal React source code. So you mount it, you can add additional style sheets, you can add additional CSS files just to simulate how application has styles on a page. And once you do that, you can use normal regular Cypress API to find a to-do button selector with text complete. So how does it look inside Cypress? Well, it looks like this. Again, on the right, you see the iframed. Well, is it a component? Well, actually, it's a single component, but mounted and bootstrapped like a mini web application. It literally is a running live application, but just a single component there, not everything you have usually in your web application. But the rest is the same. You can still open a browser, you can use DevTools, you can look at commands on the command log, you have time traveling debugger and so on. But now you're working with single component. As you can see, even styles look the same. So component tests, they say, well, I want to work to do in a full browser. And our library already, because it hooks into the Webpack for React in order to load everything correctly, it already instruments the code on the fly and reports results. So you can literally exercise the component by itself and know how much you covered in that component right away. Component tests don't have to work with like small components. You can easily load the app component, which will render to-do form and to-do. There is no shallow mounting. It's a mini web application, so you can stub things, for example, but you want to strive towards working with components in a full experience. So you see how they render, you see how they work with the children components, and not just shallow mount, but just really validates that the syntax is correct. Here's the to-do test. You import the app from the app source file, you mount it again, giving it styles like a real application would, and then you interact with that component through its DOM representation, through rendering. So component testing is coming, it's been available for a while. There is Cypress X unit test library for many frameworks. We are now solving some of the technical challenges that stopped people from using those component tests. But now I think we're close to releasing at least experimental version of component testing support that will be really nice. Okay, so one of the things with testing application and developing websites and deploying website is, hey, it works on my machine, right? But doesn't work on someone else's. But the corresponding or parallel is, well, the test passed on my machine and they didn't pass on CI, or maybe when you deployed then something broke, but you didn't test it there. So how can we solve this? If you want to run Cypress not locally like I have shown, but on continuous integration system, you usually have to do a bunch of things. You have to check out the source code, you have to do npm install to install Cypress and other npm dependencies. Usually you have to start the application locally. And when you do Cypress run, that exercise all your tests. Then you have to stop the application. But for performance reasons, you don't want to install dependencies over and over. You probably, after you install them first time, you want to cache them. So next time, when you do next build, you just restore this cache, npm install is instant because everything is already there, and then the next build is short. A typical CI configuration file kind of looks messy because you have to use checksums, you have to know what Docker image to use with OS dependencies. Maybe you have to start application. The syntax is hard to remember, and so what eventually happens is that you copy paste examples from CI providers documentation, maybe you tweak them a little bit, you push the code and see if CI runs. And usually it doesn't run on the first try, so you tweak YAML or JSON a little bit more and you push the CI file again, hoping that now it will pass. It's really frustrating experience. And if you really want to have a more realistic CI configuration where you have multiple jobs, maybe some common install and then different tests running in parallel and then maybe merging of results, it becomes complicated. You can do it in one CI, and I've done it for many, but the experience was really frustrating. So here's my opinion on continuous integration system. First, you shouldn't run continuous integration system in-house. No Jenkins, no GitLab CI, nothing. No TeamCity. You literally can buy off-the-shelf CI as a service for probably 1/10 of one engineer's salary for a month. And never worry about that. Never worry about scaling, updating, running things in parallel or one after another. So here's, out of all commercial CI providers, here are my top 3 CIs right now for running Cypress. Number 3, Netlify, which is kind of unusual because Netlify is not a continuous integration provider, right? They always call themselves either continuous deployment system or a hosting platform. But recently they introduced a concept of pipelines. And in those pipelines, you can build your website. That was always there, but now they allow you to add different plugins to the build system to customize the build process. We have written Netlify plugin Cypress that you can use from your Netlify build to run Cypress end-to-end tests. And here's how simple it is for you to run your tests on Netlify before you deploy your website. This is it. It's a single line that says, in your plugins list, package Netlify plugin Cypress. That's pretty incredible. And this plugin has JavaScript code that will install Cypress, cache it correctly, look around at your environment, figure out if it needs to start the server, run the tests, and then exit if there are no failing tests, exit, and then allow the rest of the build system to proceed. Very, very easy to use system. Number 2, silver medal, Circle CI. Circle CI has always been my favorite, but especially it got to be my favorite when they announced a concept of orbs or configuration registry. We have written Cypress.io Circle CI orb that allows anyone who uses Circle who wants to run Cypress test on Circle to do it in literally 2 lines of YAML. First, in line 3, you import Cypress orb. This is a configuration piece of YAML that is kept on Circle CI orb registry. It's kind of like npm registry, but for Circle CI config scripts. So we have written one that allows you to run Cypress. And all you have to do on Circle CI, when you want install dependencies, cache Cypress, run tests, record test artifacts, or anything really, you have to say, I want to run Cypress run job. And that jobs come from Cypress orb. That's what we have written. Now you're a user of that config and you just run that. Single line. And number 1, the gold medal goes to GitHub Actions. GitHub Actions version 2. This is, of course, if you're using Cypress.io GitHub Action package. Here's how it looks. You have your YAML that runs GitHub Actions. That's the workflow. It's pretty standard. You check out code and then you say uses, and that uses points at another GitHub repository, in this case Cypress.io GitHub-action. This one single line allows you to do everything. Again, we have written JavaScript code that sits inside GitHub Action, and then it looks around, sees if it has to install dependencies, if it has to restore previously cached dependencies, it discovers all the spec files, it discovers what it has to do to run on that particular operating system, and then it runs all your tests. When you can run tests on CI, I have another suggestion for you. You should run tests after each major code transformation. So let me explain what I mean. When we were running our application locally, we were using React scripts start, right? Which is a local Webpack dev server serving a development version of source code for easily debugging it for faster startups and so on, right? So we ran our tests because it's immediate, it's easy to modify, you can do test-driven development, all the jazz. Great, the tests run against npm start. If you want to do it on GitHub Actions, well, you use Cypress GitHub Action and you say, start the application with npm start, wait on localhost 3000 to respond, and then it will run the test. So you've done that. That runs the test first time. What's a major transformation? Well, before you deploy your web app, you probably will build a production version of it. In this case, React script comes with a build command that will minify and optimize the code. I suggest that you test your application again after building production bundle, because it's a huge change. You might be optimizing, JavaScripts, maybe inline images that actually break your application, or maybe we'll find missing resources. So we suggest that after you do npm run build on your CI, you run the GitHub action again, and in this case, you don't use React scripts anymore because you already have a static bundle in the dist folder. Instead, you use something else, just like a regular HTTP server, and you wait on that HTTP server to respond at localhost 5000. And when you run Cypress, and because the base URL is now 5000 port, not 3000, you can just pass the new value. So this will run the test again against the production bundle version of your website. So that was the second time. And again, what do you do with that bundle? You probably deploy it somewhere. In this case, GitHub is interesting because it's both CI platform and hosting platform with GitHub pages. Here's a little GitHub action for deploying the bundle that you just built to GitHub pages for that particular repo. It's literally 3 lines of YAML. So this deploys the site. Here's my suggestion. Test the app again. After deploying it, you will find maybe issues because the paths change, the bundle has changed, well, domain is no longer localhost but something else. Run maybe smoke tests. You'll see that you'll find some bugs. So here's how you do it on GitHub Actions. They have a special event. When GitHub Pages successfully finishes deploying your site, it can trigger your workflow where you can check this. If it's GitHub Pages context and then state success, now you know that your new version is there on the site, on GitHub Pages. Let's say it runs at my glebbakhmutov.com/some subpath. I can run Cypress using Cypress GitHub action again, and it will test my deploy site. Again, you can configure it and say run just like some small short test against the deploy site. But it's after big transformation, you probably should run it. This is a screenshot of GitHub Actions for that particular repo. So you can see that the first CI job ran right here. It actually ran tests before building production bundle and after, so 2 builds. And then once it got deployed, then I ran a smoke test against deployed site. And I guarantee that you will find something wrong. So read my blog post about like different things that I found before and after, and why I now recommend running end-to-end tests after each major code transformation. Never deploy a broken site. Run your test, before deploy and after. If you somehow get a broken deploy, you will find out quickly. You can fix issues and redeploy again. In conclusion, your time matters, right? As a developer, as a product owner, as an entrepreneur, you want to be fast and nimble and satisfy your customers. So demand better from the tools you use. Thank you very much. You can find the slides online. I'll be happy to answer any of your questions. Thank you.